Let's have a look at a few exercises on indices, applying the laws of indices, involving a number of problems. We will start with we look at the variety. Number one. Number one will be x is equal to 1/9. This is called an exponential equation. Now this is the same as 1 into x squared is equal to 1/9. We can apply invertendo, where we say x squared over 1 is equal to 9/1. Therefore, it's obvious that x squared is equal to 9. Now, x will equal to plus or minus 3 if I square on square root of that, or I have here x squared is equal to 9. This can be x squared minus 9 is equal to 0. This is a difference of two squares presentation here. That's x minus 3 into x plus 3. That's equal to 0. Therefore, x minus 3 is equal to 0, or x plus 3 is equal to 0. Therefore, x here is equal to 3, or x is equal to -3. We need to have two values of x because we have x squared there. Now, let's go to number 2. Number 2. Number 2, I have x exponent 2/3 is equal to 16. X 2/3 is equal to 2 to the power of 4. 2 to the power of 4 is 16. 16 can be written as 4 squared. 16 is equal to 4 squared. 16 is equal to 2 to the power of 4. So now we need to solve for x. What you do is we are going to multiply by the reciprocal of the exponent of x. Now what you do on the left, you do on the right. And then a number multiplied by its reciprocal will always give you 1. And then you say 2 here once, 2 here 2 times. 2 times 3 is 6. That is 2 to the power 6. Therefore, x is equal to 64. Let's have a look at a quadratic one. A hidden quadratic. We have here x minus 3 x to the power of half is equal to 0. Now note that x is equal to x to the power of half multiplied by x to the power of half. According to the law of exponent, the bases are the same. You only write one and you add the indices, you add the exponents. In this case, this is our exponent, and then that is that. So basically, this can be written in terms of that. This is x 1/2. Allow me to write a square because this here is the same as x 1/2 squared. So minus 3x 1/2 equal to 0. So you agree that I can take a common factor out, which is x 1/2, and what remains inside there, it is x 1/2 minus 3 is equal to 0. Therefore, the square root of x is equal to 0, or x exponent half equal to 3. Therefore, I have x 1/2 equal to 0. Here, I can square that. I can square that. I will have x equal to 0. And on the right hand side here, this is equal to 3. If I square, x will equal to 9. Let's have a look at this one here. We have 9, 2x negative 3 is equal to 27. That one should be better. In that 9 is 3 squared, while 27 is 3 cubed. So that can be given as 3 squared to the exponent of 2x minus 3. That can be written as 3 squared to the exponent 2x minus 3, which is equal to 3 to the power of 3. Now, using our power law, this is 2 multiplied by 2. It's going to be 4x minus 6 is equal to 3 to the power of 3. Therefore, the bases are the same. We equate the exponents. So 4x is equal to 3 plus 6. That is equal to 9. 4x is equal to 9. We are looking for 4x, not for 4x. We're looking for x. Therefore, x will equal to 9/4. X will equal to 9/4. Now let's have a look at the next one. This one is simple. It is 13x equal to 1. This, right, Gunjan? Yeah, it would. Wafika manje wena sisi? This is equal to 1. Now we know that any number to the power of 0 is equal to 1. So we are going to say that is equal to 13 power of 0. Therefore, the bases are the same. We equate the exponents. The next one, B here, I have 2 exponent x is equal to 0,125. Now, if we want to turn this into the above a, this is going to be 2. We need to convert a decimal into a fraction. 0,125, which we did in grade 7. Against that comma, we put a 1. Any digit, we put a 0 there. And that becomes 125 over 1,000. 25 here goes 5 times. 25 here goes. And then 5 here once. 5 here 8 times. So that gives us a fraction of 1/8. That is 2x is equal to 1/2 cubed. 2 multiplied by 2 multiplied by 2 is 8. Therefore, 2x will equal to 2 to the power negative 3. Therefore, x will equal to negative 3. That will be the value of x there. Let's have a look at another one. The next one will be of this shape. The next one will be of this form here. will be 3 x plus 1 minus 3 is equal to 54. Now here, if you distribute that, that's going to be 3x multiplied by 3 to the power of 1 into 3x is equal to 54. Now here, 3x is common. If I multiply this by that, gives me that. 3x, 3 exponent x times 1 will be that factor there. That will be 3x to 54. 3x will be 54 divided by 2. 2 into 54 is 27. We have seen something like this before. That is 3x is equal to 3 to the power of 3. Therefore, x will equal to 3. We have once more common base. Therefore, we equate the exponent. That is, x is equal to 3. Let's go and have a look at once more. This one here. This one will be of this form. This one will be 3, 9, x plus 1 is equal to 27 minus 1. And the other one will be 2x into x minus 3 is equal to 0.25. Let's start with this one first. Let's call this A and call that B. Here, this is 3, 9. Everything as 3 squared into x plus 1. This is 3 cubed minus 1. This will become 3 into 3 2x plus 2. And that will equal to 3 minus 3 there. Now you know that there's an exponent 1 here. Exponent 1 there. Now that becomes 3 2x plus 2 plus the 1 that comes from there. That will be 3 negative 3. That becomes 3. 2x plus 3 is equal to 3 negative 3. Therefore, once more, The bases are the same. We equate the exponents. We will say 2x plus 3 is equal to negative 3. So 2x will equal to negative 3. Transpose the 3 here. This is minus 6. Therefore, x will equal to negative 6 over 2, which is equal to negative 3. That is equal to negative 3. That is equal to negative 3 then. And have a look at this one here once more. Let's write on the clean page here. We have your B the B was 2x into x minus 3 is equal to 0.25. That is 2. If I remove the bracket there, I'll have x squared minus 3 is equal to 0.25. Now 0.25 is a quarter. 25 once 25 here 4 times. So that is x squared minus 3x is equal to 0.25. We said 0.25 is equal to 1/4. So 2x squared minus 3x is equal to 2 to the power minus 2. 1/4 is 1/2. Take it up. This is 2 to the power minus 2 times 1. Now, once more, the bases are the same. We equate the exponents. X squared minus 3x is equal to negative 2. That becomes x squared minus 3x plus a 2 is equal to a 0. Now, we have a quadratic in that form. Let's factorize that quadratic. We look at the first one and the last term. We forgot the middle term there. In that order, this is x squared. This is x to the power 1. This is the same as 2 times x to the power 0. Any number to the power 0 equal to 1. So in that order, 2, 1, 0. We take the first one here and the last one there. The factors of x squared is x multiplied by x. Factors of 2 is 2 and 1. I have a plus here, so it's going to be negative 2 multiplied by negative 1. That gives negative 2. Now look at what happens to the middle term that I forgot. If you multiply here, you get negative x. If you multiply there, you'll get negative 2x. The signs are the same. We add, we have negative 3x. Your middle term comes up. So basically, the factors of this quadratic is x minus 2 into x minus 1. That is equal to 0. Therefore, x minus 2 is equal to 0, or x minus 1 is equal to 0, where x is equal to 1 and where x is equal to a 2. That was a lovely one because it calls for a number of skills here. Let's go and have a look at the other one. By the form of 2x plus 2x minus 6 is equal to 0. Now that is also a quadratic. Why? Because 2x squared is 2 to the power of 2x there, which is the first term. So this can be written, the whole thing can be written as 2x squared plus 2x minus 6. So we look at the first one and the last one, and then we can say the factors here will be 2x multiplied by 2x for the first one there. And then for this one here, the factors will be 3 multiplied by 2 see what happens here. We have 6 minus 3, okay. And then this sign is positive. The bigger one must be positive. The smaller one must be negative. If I multiply these two here, I'll definitely get that one there. So, which means here, the factors becomes 2x plus 3 into 2x minus a 2, that is equal to a 0. Therefore, 2x plus 3 is equal to 0, or 2x minus 2 is equal to a 0. 2x is equal to 2. Therefore, x is equal to 1. Because there is a 1 there, because there is a 1 there, the bases are the same. We equate the exponents, or the side here, we have 2x is equal to negative 3. This one does not have a solution because if you solve that and you use the logs, this can be x, the log of 2 is equal to the log of a negative 3. You don't have a log of a negative number. So the only solution is that x is equal to 1. Let's have a look at this one here. There is x, exponent x multiply by a squared to the root of x all over a to the power of 5 is equal to 1. On the left-hand side, I will have a exponent x multiplied by a squared to the power 1 over x is equal to a exponent 5 minus x is equal to 1 over 1. I can multiply both sides by the denominator, which is a 5 exponent 5 minus 1. Two ways of doing that. I can multiply here by a 5 minus x, multiply by a 5 minus x. That will drop. I'll have a power of x multiplied by a 2 over x is equal to a 5 minus x. Now, if I multiply the powers that have the same base, the powers that have the same base, I add the exponent. I'm going to write only one. It's going to have x plus 2 over x is equal to a 5 minus x. Now, once more, it's obvious that the bases are the same on both sides. Therefore, x plus 2 over x is equal to 5 minus x. Now, if I transpose that, I'll have x equal um, equal 4,000 equal kunelitshe ngaphandle lapha yebo ngenani yebo sure